Example 5 has to do with the angle addition postulate. The angle addition postulate is very similar to the segment addition postulate, except instead of adding two segments together to get the whole thing, we're going to add two angles together. So if we look at our formal definition or the postulate itself, if point D is in the interior, so interior means inside, so inside of angle ABC, so here's angle ABC. If I exaggerate the angle out a little bit. So there's angle ABC. Point D is in the middle. And if that's the case, then we know that the two small angles, angle ABD, this angle here, ABD, right, angle ABD, and then angle DBC, so I'm sorry, I did it the opposite way. So ABD is this angle, the blue one, right? ABD. Okay, and then the green one here is DBC, so DBC, right? So the green one. And then ABC was the whole thing. So basically the two small angles here, the two parts are going to add up to the whole thing. Okay, because these angles share a ray in common. If we add them up, they're going to equal the whole thing. Right? So the measure of ABD plus the measure of DBC is going to equal the measure of angle ABC. Okay, if this is the case, then that's the case. All right, and then this is just giving you a chance to explore what's going to happen here. If we notice right now, it says you have, if I zoom in a little, oops, right, this angle's 30, this angle's 30, and then they add together to get 60. If we spread them out, you can see that this angle, it's hard to see they don't do a good job of putting that other one somewhere else, right? So we have 66, this angle here, ABC, is 66. This one down here, DBC, is 49, and they add together to form a BD, which is going to be 115. So this angle here is 66, this angle here is 49. Together they add up to 115, so this big angle here is 115. All right, let's get on to the example problem. So example 5 here. All right, so a lighting designer is finalizing the lighting plans for an upcoming production. The spotlight can rotate 25 degrees to the left or the right from the center. The beam of light from the center forms a 22-degree angle. Can the designer use the spotlight to light each of the objects on the stage? So let's look closer at this problem here, or let's redraw it. It's probably a better way to do it. So let's draw the beam of light. Oh no, let's zoom in on their diagram actually. Changing things on the fly here. All right, so their beam of light is going to be this angle here. I will draw it again, I think. So let's draw the beam of light. Here's the beam of light. This angle here is 22 degrees. Right, we have the table here. The table here. So there's a table out here. Okay, and then there is a chair over in this direction. Okay, they're letting us know this whole angle, the entire thing here. So maybe I'll do this in blue. The whole big angle here is 74 degrees. Small beam is 22, and we also know that this angle here, from the chair to the door, this angle here from the chair to the door, that's going to be 57. All right, and we know we can rotate this beam. That's the yellow one. The yellow one was the beam. we can rotate it 25 degrees to the right, 25 degrees to the left, and our goal is to see if we can hit the chair and the table. So chair's over here, table's over here. We need to see if we can hit those objects. So what we need are these two angles here to be less than 25 degrees. If they're less, 25 degrees or less, then our beam's going to be able to rotate and hit, right? So if this angle here is less 25 degrees or less, we'll be able to hit the table. If this angle over here, run out of colors, let me just put, let's put red in here. If that's less, 25 degrees or less, we'll be able to rotate the beam over to hit the chair. Okay, so we have to use our angle addition postulate. So we know, let's call this x, right? We know this angle, x, plus the 22 degrees, right? This small angle and this small angle, if we add them up, we should get 57, because we know this angle here is 57. Its two parts are x and 8. So we know that x plus 22 should be equal to 57. All right, and we can now subtract 22 from both sides. All right, 57 minus 22, that's going to give us x equals 35. So that's 35 degrees. All right, so 57 minus 22 is going to give us 35 degrees. And our beam can only rotate 25 degrees, so it's not going to be rotate far enough to be able to hit the chair. Right, this beam here can, like this angle here, we just found this to be 35. Right, and we can only rotate it 25, so the beam's not going to be able to hit the chair. All right, to find the, let's call this y, to find y now. Right, we know that the whole big angle here is 74. We know that this piece is 57. So we know 57 plus y should give us the whole thing of 74. So 57 plus y should give us the whole thing of 74. This piece here plus this piece, right? This piece, right? This piece is this piece, should give us the whole thing, right? The 57 and then the y should give us the whole thing. So we add those together to 74. So we subtract 57 from both sides. And we get y equals, oops, definitely not x. It's going to be in the way now. We'll make it y equals 74 minus 57 is going to give us 17, right? So 17 degrees, so it is going to be able to rotate, right? It can rotate 25 degrees. It's going to be able to rotate far enough to be able to get on that table. Okay. You guys now have the try it down here, so you can do the try it.